Okay, we're almost done here. So, flooding happens when snow melts or heavy water, heavy rain, swells the volume of a river so it spills out onto the river's banks. I'm sure you are aware of what flooding is. So, a lot of times, in the long term, floods are ecologically beneficial because they spread out the nutrient-rich sediment over large areas. So now we are spreading the fertility and creating fertile floodplains, if you remember from earlier this lesson. However, in the short term, floods are damaging. Lately, with all this rain I've been getting a lot of flash flood alerts, which is not happening here, but that's because they can be damaging. They are damaging to the property of people who live in the floodplains. So to protect against floods, levees levees are built along the banks of water to hold in the main channels. So what we do is we're preventing small floods, but kind of like fires, it can lead to bigger, more catastrophic floods because we're holding in more water. And if something were to happen to that levee, or if it were to get so bad that it overflowed, now there's more water to flood. And that's what happened in Hurricane Katrina. The levees all broke, which is what led to such bad flooding. So what we can do, or what we do is that we divert surface water to suit our needs. So for example, in California, aqueducts channel water from the north and the east to the state's central agricultural valleys and coastal cities. So these are all the blue is the major rivers, the yellow is the federal aqueducts. We have state aqueducts and local aqueduct projects. So the California State Water Project, which is a 1,100 kilometers of pipelines, joins the federal Central Valley Project to make one of the most extensive artificial waterways in the world, which is why we have so much farming and so many cities in such a dry region, is because of these aqueducts. And so the water flow is driven mainly by gravity, but in some places we do have to pump water over mountains in specific regions. And so these aqueducts have allowed California's Central Valley to become one of the most agriculturally productive regions in the world, but it has dried up the surface water sources in other areas such as Mono Lake. So we took water from the rural Owens Valley, which is about 220 miles away, and we kind of turned those regions into dust bowls and destroyed their economy. So this is Mono Lake. It's super receding, and there's an aqueduct flowing through the Central Valley. That's why if you've ever driven to Northern California on the 5, smells really bad because of all the agriculture and all the cows that are there. We have also built lots and lots of dams. So a dam is any obstruction placed in a river or stream to block its flow. And the reason for that is usually to create a reservoir, which is an artificial lake. So as we stop a river from flowing, the water builds up behind it and creates this body of water. And so the dams help to prevent floods. They provide people with drinking water, they facilitate irrigation, and they can generate electricity. And worldwide, there are more than 45,000 large dams. So there's a lot of good things and a lot of bad things about dams. So one is that the good things are that they create this reservoir, which can be reliable drinking water if the watershed lands are protected. So if the land that the water is running off of into the reservoir is safe, then we can safely drink the drinking water. We can have reliable irrigation for farming because now we have a source of water to get irrigation for. We can generate renewable electricity, so hydroelectric power. As water flows downward, we can harness that kinetic energy into electricity. They do flood control by storing seasonal surges, so the water is stored there instead of flooding, as well as creating new recreational opportunities. However, 40 to 80 million people have been displaced by dam projects in the past 50 years. So as they're building these dams, they're creating where there was just land because it was a river, they're flooding it. And so anyone who lived there has to move. The sediment often, so the rivers are flowing and then they stop here. So sediment will settle behind the dam, which will fill in the reservoir. And now downstream, the plants are not getting the nourishing sediments that they had been getting before. There's a small risk of catastrophic failure, which we'll talk about. We have habitat alteration, both upstream and downstream. Both of them look different on either side of the dam. We have lost recreational opportunities on rivers. So this poor guy just wants to float on the river. I know he can't anymore. Our fisheries decline from thermal pollution and blockage of the migration. So the fisheries are not getting the fish anymore because we blocked their pathway. The disruption of flooding that builds topsoil. So the flooding does give us those fertile floodplains, and now we're stopping that. So there's a lot of pros and cons. So So there's this new dam. It was built in 2000, sometime in 2000. And it's the Three Gorges Dam on China's Yangtze River. And so the positives were that it provides flood control. It enables boats and barges to travel further upstream. It generates enough hydroelectric power to replace a lot of, or dozens of large coal or nuclear plants. So it's a lot of clean energy. However, there's the PowerPoint only lists the cost. So it costs $39 million to build. The reservoir flooded. So we dammed a river, and so now behind it, we created a reservoir. It flooded 22 cities, farmlands, and habitats while displaced 1.24 million people. So this dam made 1.24 million people move. Now we're depriving the coastal marshes of sediment, causing them to erode away. And so there's a lot of pollution in this region in China, and now all of the pollution is trapped behind the dam. And what they're really worried about is if there were to be an earthquake and this dam would break, it would be catastrophic because it would lead to a bunch of dam failures further down the river and basically just tons of flooding. There was an example of an earthquake in 1975 that led to a bunch of dam failures and it killed 26,000 people. So having something this big could lead to a really catastrophic event. So some dams are being removed these days because they were built for economic benefits, and now they're not really providing us with those economic benefits anymore, and they still have the environmental impacts. So those who argue that the costs of dams outweigh their benefits promote the idea of dam removal, so removing them and allowing the river to flow again and getting rid of that reservoir. So these would restore riparian ecosystems. If you remember, the riparian ecosystems are the ones along the edges of rivers or streams or lakes that get flooded and drained occasionally. We could reestablish the fisheries because the fish could not swim upstream anymore if there's a dam, so the fisheries go out of business. We could revive river recreation such as fly fishing and rafting. The return of shellfish and fish habitats in and around the mouths of rivers have been disrupted by the dam, so they would return. So roughly 400 dams have been removed from the United States in the past decade. Because, like I said, they are in need of costly repairs or no longer economically useful. So I added this Federal Energy Regulatory Commission, the FERC, because that is the government agency charged with renewing licenses on dams. So either deciding if it's going to keep going or if they should take it down. So this fever to take down dams started in 1999 with the Edwards Dam on the Kennebec River in Maine. And so the environmental benefits of removing it outweighed the economic benefits of keeping it. And so after 1 year of removing it, 10 species of migratory fish had returned upstream to the river. So they considered that a success. A movement is underway to remove the O'Shaughnessy Dam on the Tuolumne on a river in Yosemite National Park. And so this is in 1907, there's the river right there. Now this is the same basin, and now there's the dam, and so now there's a big reservoir. So this is called the Hetch Hetchy Valley. So it would drain the valley and return it to its original state. It would restore the native plants and animals that lived there before the reservoir, so it would have a lot of environmental benefits. However, San Francisco gets a lot of its water from this reservoir, and so they're worried about providing enough drinking water for their people, so they do not want that to happen. So we need to come up with solutions to the depletion of fresh water. So as population growth is happening like crazy, you know that expansion of irrigation and industrial development have doubled our use of fresh water over the past 50 years. So we need to address the water shortages by either increasing our supply or reducing demand. That's the only way, right? Either we make more of it or we use less of it. So we have what's called desalination. Oh, we're in the next lesson. We're going to stop here.